Okay, so we're going to continue on with our multivariate linear systems. And as I said, we've talked about the row operations, and in this video here, I'm just wanting to do a couple example problems. So let's go ahead and start off here. I've got x plus y plus z equals 6. And then we've got 2x minus y plus z equals 3. And then we've got 3x plus y minus z equals 2. Now, I think what you'll see here is that these problems, while they're not precisely what I would consider difficult, they can be somewhat time-consuming to get done here. So there's lots of ways. There's no one way to get to this row echelon form, but remember what we want here is we want the first equation to have x, y, and z, the second equation to have y and z, and then the third equation to have just z in it. So I like to start off by just looking at, okay, I want to get rid of the x's here because I don't want x's in these two equations. If my first equation is the only one that has an x, I want to get rid of these. So what I'm going to do is I'll kind of put a little bracket here with an arrow, and I like to write down what the operation is I'm going to do. Well, to get rid of this 2 here, if I multiplied this first row by -2 and added it, I would be able to do that. So I'm going to say -2 row 1 plus row 2. Now remember, that's got to get stored in row 2. So we're only doing one row operation at a time. So I have x plus y plus z. Come on. There we go. Plus z equals 6. Now let's do this row operation. So I have -2 row 1. So I have -2 times x, -2x plus 2x. That's 0. So I'm not going to write anything. Then I have -2 times y. So I have -2y plus -y. So that would be minus 3y, -3y. -2 times z is -2z plus z, so that would be a minus z, is equal to, well, then I have -2 times 6, which is -12 plus 3, so -12 plus 3 is -9. And now I haven't done anything else to this other equation, so I'm just going to have 3x plus y minus z equals 2. So the second equation is kind of already what we want, but I'm going to make life a little bit easier. Notice how I have all these negatives. Let's just multiply. So I'm going to kind of put my row operation here. My row operation, I'm going to just do -1 times row 2, because that was a valid row operation as well. And so if I do that, top equation doesn't change, x plus y plus z equals 6, and then the next equation just becomes 3y plus z equals 9, and then I still have 3x plus y minus z equals 2. Okay, well then we're going to do the same thing here. I'm going to multiply. In this case, I'll just go ahead and write it in red. I'm going to take this to another set of equations, and I'm going to look here. I've got one more x I need to eliminate. So I'm going to do -3 times this row plus this second row here, or this third row. So I'm going to have -3 times row 1 plus row 3. And so this is equal, well, the top equation isn't changing, so I have x plus y plus z equals 6. I'm not doing anything to the second equation, so I have 3y plus z equals 9. Now let's go through and do this bottom one here. So I got -3 times x, -3x plus 3x is 0. -3 times y, -3y plus y, so I have -2y. -3 times z minus z, that'd be -4z. Negative 3 times 6 is negative 18. Negative 18 plus 2 is equal to negative 16. Alright, now before I move on, I'm going to again notice there's a negative here, but also notice that everything here in this last equation is a multiple of 2. So I'm actually going to go ahead and do 1 negative 1/2 row 3. Okay, so then what do I have here? I've got x plus y plus z equals 6. And then I've got 3y plus z equals 9. And then negative 1/2, that would be positive y plus 2z equals 8. Now I've got one final one to do here, and that's getting rid of this y here. Now you want to be careful here. You don't want to use this top equation to try and get rid of that y. That might be tempting, but if you do that, you're going to incorporate an x. So you want to use the second equation here and the third equation to get rid of this y. So we're in the echelon form and can do back substitution. And so what I would do here is I would do negative 3 row, let's go ahead and do negative 3 row 3 plus row 2. Now where do I store that? Remember, you always store it in what the row you're adding to. So this is actually going to get stored in row 2, but it's going to eliminate the y. So what do I have here? I've got x plus y plus z equals negative 6, and then I'd have negative 3 plus negative 3, so that's 0. Then I have negative 3 times 2, which is negative 6, plus z, so I'd have negative 5z. And then I have negative 3 times 8, which is negative 24. Negative 24 plus 9 is negative 15. And then the bottom equation I didn't change. But now I can clearly see here that I can swap. I'm going to swap 2 and 3. Because if I do that, I have x plus y plus z equals negative 6. And then I've got y plus 2z equals 8. And negative 5z equals negative 15. Which then we can clearly see here, if you have negative 5z equals negative 15, you've got z is equal to 3, and then we back substitute, so we get here y plus 2 times 3 equals 8. So then y would equal 2. And then we have x plus y, which is 2, plus z, which is 3, is equal to negative 6. And that would mean that x is negative 11. So our solution, remembering that you write it x, y, z, would be negative 11, 2, 3. So I really don't think the problems are hard. They're just a tiny bit maybe tedious just because of the length of the problems. So let's look at one more example of this here. So we have x plus y minus 2z is equal to 3. 3x minus 2y plus 4z equals 1. And then 2x minus 3y plus 6z equals 8. Okay, so now what are we going to do here? Well, same thing as we did before. I've got this nice 1 here. So let's go ahead, and the first thing I'm going to do is try and get rid of those x's. So I'm going to do -3 row 1 plus row 2. And of course the top one is still x plus y minus 2z equals 3. Now the second one here, well, those would be 0. -3 plus -2 be -5y. This would be +6 plus 4 plus 10z, -9 plus 1, -8. And then we'd have 2x minus 3y plus 6z equals 8. Then we simply do another row operation to get rid of this other x. So we do -2 row 1 plus row 3. And if we do that, we'd wind up with x plus y minus 2z equals 3, -5y plus 10z equals -8. And then, of course, -2 plus 2 is 0. Then I'd have -2 plus -3, so that would be -5y. And then I'd have -2 times -2, which is 4. 4 plus 6 is 10, so plus 10z. And then we'd have, sorry, there's a glare on my screen. I can't see what I've got here. -2 row 1, so -2 times 3 is -6. -6 plus 8 is equal to 2. Alright, so now we can see that, well, I want to cancel this out, but notice here I've got a 5y and a -5y and a -5y. So I can just do, let's say, -1 times row 2 plus row 3. And if I do that, what do I get? Well, top equation doesn't change. X plus y minus 2z equals 3. And then what do you have here? We have -5y plus 10z. So that's not going to change because that's the equation I'm multiplying by. Okay, come on. There we go, equals -8. And now, of course, we just do negative, so I have -1, which would be 5 plus 5 minus 5, which is 0. And then I have -10 plus 10, which is 0. So I'm going to have 0 is equal to, and then I'd have 8 plus 2, which is 10. Now this should look familiar because we had this in the last couple videos ago, and if we had this when we had two linear systems with two variables, we got that there was no solution. And we get the same thing here. This is no solution then, because 0 clearly does not equal 10. And this is what's referred to as having it be inconsistent. Now, the same idea would happen if you wound up with a 0 equals 0. That would mean that you have an infinite number of solutions. Now there's one more thing I'd like to talk about before wrapping this up. And the last thing I'd like to talk about is what happens when you get non-square systems. Oops. What do I mean by non-square systems here? Well, let's look at an example problem. And a non-square system is, if the examples we've been looking at, we've had 3 equations and 3 unknowns. A non-square system is where you might have 2 equations and 2 unknowns. Or, I'm sorry, 3 equations and 2 equations and 3 unknowns. That's correct. Sorry. Took me a while to spit it out correctly here. So let's look at an example of that here. So let's look at x plus 2y plus z equals 2, and then 2x minus y minus z equals 1. And so this is going to be my system. Now, right away, since this has only got 2 equations, it doesn't mean we have no solution. In fact, it means the opposite, is we're probably going to have an infinite number of solutions. But we're still going to put it in the echelon form here. But it turns out there's only one step we need to do here. And all I'm going to do here is I'm going to do -2 row 1 plus row 2. And so if I do that, I have x plus 2y plus z equals 2. And then of course I'd have -2x plus 2x, which is 0. Then I'd have -4 plus -y, so that's -5y. And then -2 times z, which is -2 plus -1, which would be minus 3z. And then I've got -2 times 2, which is -4 plus 1, which is -3. Alright, I just realized I made one mistake here. That's why I was pausing here and kind of confused a second. And again, there's this really awful glare on my screen right now, which is causing some of the issues here. I think I might have to see if I can turn my lights off or something. So I made a mistake here on the... Actually, no, I didn't. This is correct. I thought I made a mistake here because I have -2 times 2, which is -4 plus -1 is -5. Yeah, so no mistake. Alright, but this is actually in its kind of echelon form here. I've got just x here, and then I have my stair-step pattern. But okay, well, what do we do here? How do we solve for this? Well, what we do here is this is where we have what's called a free parameter. And this is how I said parametric equations. Well, this is actually an example of it, and we're not going to go into a super amount of detail, but basically, since this equation here, 5y minus 3z, -5y minus 3z equals -3, there's essentially an infinite number of solutions to that as well. We just say, okay, well, let's let z equals, I like to use t for my parameter. So I'm going to just say z is equal to t. And then I'm going to look at that equation. I have -5y minus 3t equals -3. Then we're going to solve this for t. And so if we solve that for t, we'd have, not t, I'm sorry, solve this for y. T is the parameter. Solve it for y. So we'd have -5y is equal to -3 plus 3t. Then I'm going to divide by -5. And I'll go ahead and put this down as a decimal here, because dividing by -5 gives you a clean decimals. So -3 divided by -5 is, of course, 0.6. And then I'd have minus 0.6t. So that's what y is. And then I'm going to still do another back substitution. So you'd have x plus 2 times 0.6 minus 0.6t plus z is just equal to t. And I'm going to solve for x. So you have x plus 1.2 minus 1.2t plus t equals 2. So we'd have x and minus 0.2t is equal to 0.8, and so x is then 0.2t plus 0.8. So the solution here looks a little bit weird. The solution is 0.2t plus 0.8, comma, let's try this again here, comma, 0.6 minus 0.6t, comma, t. And then the key here is t is any real number. So there are an infinite number of solutions, but this is, we've displayed all of them. Now, if this problem seemed a little confusing, don't worry too much. This isn't going to be a very big portion of this. I just wanted to do one example like this. Okay, now this really wraps up our systems of equations here as far as using these row operations. Before I end the video, though, I'm going to go back up to our very first example. And I want to emphasize here, when we were doing all these row operations, all we were doing was adding and subtracting the coefficients in front of the variables. And so that key piece of information right there is going to lead us to a more neat way to write these down. And quite frankly, I think it's not necessarily any quicker, it's just keeping your work straight. I find you make fewer mistakes. And that's going to lead us into matrices.